So far, we have examined standard system attacks, physical protection, controlling access, and securing data. Now, we will examine the details of securing communications. And actually, uh, if you want to listen to the particular stations, let's say the FM on the radio, you have to tune your radio or let's say receiver to the same frequency on which that station's transmitter is broadcasting. Let's say you want to listen to Barek International in the North Cyprus, one of the famous radio stations, and the frequency is 106 megahertz, and you have to tune your radio to that according frequency. And actually any user within listening range of the transmitter can tune to the same frequency and listen. Okay, let's say that it works well for commercial radio, but it has always been a serious problem for the military, because when one side transmits military information, it generally does not want the enemy to be able to hear it. And in such cases, somehow the transmission must be made secure somehow. And actually, even if it captured by the enemy, it shouldn't be understood. That's also another key point. And one of the oldest methods for securing the data in order to transmit without having any trouble. Uh, the spread spectrum technology is used, and actually, it transmits the data, let's say, not in a fixed bandwidth. It transmits, it spreads it over a wider bandwidth, and by spreading the data, level of security is incorporated, and it's more difficult to wiretapping or eavesdropping the signal. Actually, one of the most common commercial applications of spread spectrum technology, SST, is wireless communication. And there are two basic spread spectrum technologies. One is frequency hopping spread spectrum, and other one is direct sequence spread spectrum. And we will examine each of them in very detailed way.